device that which helps detect and measure the distance of any nearby objects without any physical contact. So this is basically the proximity sensors. Okay. So the maximum distance that a proximity sensor that can detect, so that is called as actually nominal range. Okay, the nominal range. So proximity sensors basically, application. There's so many applications. Household, from household to wide range of application, industrial application that is it is widely used for proximity sensors nowadays. So basically, it is in monitoring, the and machine vibrations. Okay, to measure the variation, distance between the shaft and any support bearings. Okay, so this is very common, in a large steam turbines, compression motors. Okay, they are widely used in general, industrial automation, such as conveyor belts. If you visit an industry, so you can see the conveyor lines, the conveyor belt, jam detection purpose. Okay, counting purpose, food counting process. Okay, the safety interlock system. So there are so many, there is a industrial widely used in industry. Okay, proximity sensors in our daily life that you are using in a mobile phone. Okay, that it consists of the IR technology. Okay, so in the mobile phone, at the top of the phone, that is the proximity sensor is mounted in a mobile phone. Parking sensor, car parking sensor. So that is the proximity sensor. Proximity sensor that is used. So daily life also, dealing with so many proximity sensors, many optical proximity sensors. So there's a types, basically capacity proximity sensors, inductive proximity sensors, optical proximity sensors, Hall effect proximity sensors. Okay, so there are different applications. Okay, so what are the features actually? The features that I have highlighted. First one is that is a very special features, that is a contactless sensing. So that contactless sensing means allows for detection without touching the object. So that is the contactless sensing. Next one is that the unaffected. It's not affected by the surface conditions. Okay. So basically, the proximity sensors, nearly not affected by any surface colors of the objects. Basically, see, it mainly detects only the physical changes. Okay, detects only the physical changes, right? So next one is the suitability for a wide range of applications. Just now I have just said, a wide range of applications. These are suitable for damp conditions also. Wide temperature range uses. Okay, unlike other traditional optical detection. Okay, and I just now have said that is applicable in your phone. Okay, maybe your Android phone, iOS device, whatever. So it consists of simple IR technology. Okay, so actually what is happening there? That phone is switch on off display according to your users. Okay, so that is the proximity sensor, because of the proximity sensors. Okay, because it turn off your display when the phone call is ongoing. We know that when the phone call is ongoing, that turn off your display. Okay, so such that you would not accidentally activate to something while placing it near your chips. Okay, so that is the suitability for the wide range of application. Thus, where the proximity sensor is installed, the mounted in your mobile phones, okay, your smartphone. Okay. So next is the long service life. Okay, long service life. The long service life means that actually it is a non-contacted device, contactless device. So there is no any moving part. There is no any moving parts is there. Okay. So that's why the service life, here, tends to be longer as compared to the other traditional sensors. Okay. So that is a longer service life. Okay. So as it is a contactless device, so there is no moving parts. So basically, that's why the service life tends to be longer, tends to be longer as compared to any traditional sensors. Okay. Next one is the high speed, response rate. Another feature. features, high speed response rate. So basically, you know that compared to the switches, where switches means the contact is required, for sensing. Okay, but in the proximity sensors, it does not require for that. So it's offer a higher speed response, higher speed of response. So these are the special features, 1, 2, 3, 4, 5, the 5 features that proximity sensors have. One is that contactless sensing. Second one is that unaffected by any surface conditions. Third one is that suitability for a wide range of applications. Fourth one is that longer service life, and fifth one is that high speed response. Okay. So this is the proximity sensors. That is advantage. You may say that it is a features or advantages, and is the applications. And the next, if you move to the classification, mostly important, that is capacitive and inductive type proximity sensors. Okay, capacitive and inductive type proximity sensors, and except the capacitive inductive proximity sensors, other proximity sensors also that is optical proximity sensors, Hall effect proximity sensors. Okay, another that is the ultrasonic proximity sensors. Ultrasonic proximity sensors. Okay, there are 5 types of proximity sensors. Okay. So this is the image that is of inductive proximity sensors. This is the image of the inductive proximity, because what is actually the inductive proximity sensors? Okay, so basically see the structure, see the image clearly. So basically, the inductive proximity sensors is we know that it is a contactless sensors device. Okay, and that is used to only detect the inductive proximity sensors. Basically, used to only detect the metal objects. Okay, only the metal objects. Okay, it is used to only detect the metal objects, right? And it is the based on basically the law of induction. Okay, law of induction driving a coil, okay, with an oscillator. Okay, once the metallic object approach when the metallic object approach it. Okay, so basically this is the inductive sensor, inductive proximity sensor, that consists of one the inductive coils followed by the oscillator electronics, Smith trigger circuits, output switching circuits. Okay, and which one is the target? The device is, this is your target. Okay? This is your target. This is the target or object. Okay, so you have to vary this object. You have to change the distance of the object. So accordingly, you can take the several readings in the laboratory in experiments. Okay. So actually, what is happened basically is very simple operation. Alternating current first is supplied to the inductive coil. Okay, alternating current first supplied to the inductive coil, and generating here electromagnetic detection field. Okay, in generating electromagnetic detection field. So when this metal object, this is suppose the metal object. Okay, basically when it comes very closer, very comes closer into this magnetic field. Okay, when it comes closer into this magnetic field, then what will happen? It builds a eddy current. Okay, it builds a eddy current and results in the coil induction changes. Okay, so alternating current first you have to supply in the coil to generating the electromagnetic detection field. So when this object, this metallic object, it comes very closer. Okay, so comes very closer. Okay, so comes means it is a contactless device, touchless device. It does not contact, but when it comes, then it will automatically sense. Okay, when this metal object comes very closer into this magnetic field, then what will happen? It automatically builds the inside it, the eddy currents. Okay, and results in the coil induction changes. So when the coil induction changes, then what will happen? The circuit that has been continuously monitoring will trigger the the sensors output switches. Okay, means here the oscillator circuits is there, oscillators is there. Okay, oscillators changes because the oscillators, because that when this magnetic field is produced, okay, so what will happen? Because in the inactive coils, okay, so it is eddy current when generates the eddy current, builds eddy current, it flows through the circuits. Okay, as a result, you may say that the flux around this coil, some electric magnetic flux this around this coil, that is reduced. Okay, it is reduced with a consequent reduction, of this inductance of this coil. Okay, so basically this effect, depends on the distance between this target and this coil. Okay, this effect basically depends between this target and this coil. Okay, so because the nearer the target, what is the operation? Nearer the target to the coil, the higher the eddy currents. Okay, and lower the inductance, vice versa. Okay, so if the target is very near to the coil, that means eddy current will become higher. Okay, if the target is too far from the target, from this sensor, then what will happen? Then a small amount of eddy current will be generated. A small amount of eddy current will be generated. Okay. So this is actually the basic basic workings of this inductive type proximity sensors. Okay. And this inductive type proximity sensors basically common uses industrial production automation machines. Okay, a inductive proximity sensor that is used in a production automation machines. So basically that counts the products. Okay, that counts basically the products, or and detection of where if you see in other application like some detection of any metal objects, because okay, suppose a bridge is there, this is a capacitance, this bridge is there. Okay, there is one bridge, there is one bridge circuit. This is your bridge circuit. Okay, we'll draw first. Goes to resistance. Okay, goes to resistance. The bridge circuit. Okay, so now what will happen? This is the two capacitors, one capacitor and two capacitors. Now what will we do? The two the coils. Okay, basically these coils, there are two coils. Okay, there are two coils, inductive coils. Okay, the two inductive coils basically, one acts as a active coil. This one's first, suppose first coil. This first coil is an active coil. Okay, and this second coil that is suppose acts for balancing purpose. Okay, for temperature compensation purpose. So these two coils actually connected. It has to be connected with these two capacitors that forming the two arms of the bridge. Okay, so suppose I am connecting here the I'm connecting these two coils, parallel connection, parallelly connected with the capacitors, parallelly connected with the capacitors. Okay, this one, and from this line is to this one. Okay, this one. Okay, and so this is your detector. This is the detector. This is the detector, and this has to be connected. Suppose this is the ground. This is the ground. Okay, this is the ground. Okay, fine. So actually the circuit looks like that. So this probe actually consists of the two inductive coils. This is the first coil, and this is the second coils. So first coil acts as one active coil that for measurement purpose, and this second coil acts for the balancing purpose, for temperature compensation purpose, right? So now actually what will happen? So distance between the target and the probe. This is your target. Okay, this is your target or object. Distance between this distance between this target and the probe. This distance determines the inductance in the additive coil. Okay, determines the inductance in the active coil. Okay, so now if we connect here some other signal conditioning element, so like suppose this is your PSD, that is a phase sensitive detector. This is a phase sensitive detector. Okay, and the next one is the suppose filter. Okay, because it's a filter, that is suppose it is your low pass filter. There is a low pass filter. Okay, this is a low pass filter, and this is the indicating meters, and this is your indicating meters, right? So actually when the bridge is balanced, so any displacement of this target, causes the bridge unbalanced. So produce some voltage through the bridge, that is proportional to the target displacement. Okay, so target displacement, is the target some displacement kar raha hai na, nearer to the in the probe. So क्या होगा कि automatically the voltage will be generated. Okay, voltage will be generated. That voltage that will be output will be proportional to the this displacement. Okay, so now this unbalanced bridge. Now what we have to do? This unbalanced bridge has to be demodulated. Okay, this unbalanced bridge has to be demodulated. Okay, that is with the phase sensitive detector. Phase sensitive detector. Okay, and low pass filter followed by this low pass filter. What is the need of this low pass filter? Suppose we are having noise, so how to eliminate the noise. So you have to use the low pass filters. Okay, you have to use the low pass filter, to produce, it can produce the DC output voltage. Okay, it can DC output voltage. Okay, so now this can be calibrated. This can be calibrated here to this indicating meter. Okay, so to indicate the, to indicate the extent of this target displacement. Okay, so this is actually, practical setup. When you will do the experiments, when you perform these experiments. Okay, so you will be facing this type of circuits. Okay, so you have to take the several readings. You have to change this displacement accordingly. That you have to measure the inductance from the active coil, and as well as you have to measure the voltage that is proportional, should be proportional to this displacement. You have to take the several readings in the voltage. Okay, so now that can be calibrated directly here to this indicating meter. Okay, to indicate the extent of the target displacement. Okay, so this is all about, that is inductive proximity sensors. Clear? Inductive proximity sensors. Clear?
Yes, sir.
Yes, sir.
Okay, so this is the several advantages and disadvantages also that I have mentioned. The advantages of inductive proximity sensors, that is the contactless connection, environmental adaptability, resistant to common the conditions seen in the industrial areas such as dust standard, capable and versatile in metal sensing, considerably thus cheap when it comes to the price. Okay, there is no moving parts, ensuring the longer service life. So these are the common advantages. Disadvantages, that is a lack in the detection range because it depends on nominal range. Okay, so average maximum range up to 80 millimeters. Okay, so suppose say are by 80 millimeters, maybe above the 80 millimeters, between 120 millimeters, maybe like that. Okay, so can only detect only the metal objects. So performance, can be affected by some external condition also, like extreme temperature. Extreme temperature, so performance can be affected. Okay. So these are actually the several advantages, disadvantages of these, inductive proximity sensors. And next one is the capacitive proximity sensor. What is the capacitive proximity sensors? Okay. So see the diagram very carefully in the case of the capacitive proximity sensors also. So capacitive proximity sensors, actually, you know that what is the capacitor? Capacitor, that basically the two parallel plates are there. So two parallel plates are there. Okay. So actually, what is happening here in the capacitive proximity sensors? First, see that the capacitive proximity sensor consists of one oscillator, same trigger circuits and output switching device, and there is a target. Okay, the same thing, same management is there. Okay, so the capacitive proximity sensor, we know that there are two plates. There is a two parallel plates, one plate and another plate, two parallel plates. So here the first plate acts as a internal plate. Okay, and another plate acts as a external plate. So this is your internal plate, and this is your, suppose, the external plate. Okay. So this internal plate, you can see this diagram, this internal plate actually, that is connected to the oscillators, followed by the triggering circuit, followed by the output switching device. And the external plate, what is the need of this external plate? That is used as a sensing surface. This is what? The sensing surface. Okay. So this is actually the sensing surface. Okay. And this is the target. So this plate, this one plate acts as a sensing surface, and this one plate acts as a, that is a connected internal plate, inner plate. So that is connected to the oscillators and electronic circuits, connected to electronic circuits. Okay. So these two parallel plates. So what is the operation? Operation is there. So capacitive proximity sensors, basically, it is also contactless sensors, but detect both the metallic and non-metallic objects. Okay. So including some liquid, powders, whatever. Okay. So this is the advantage. Both metallic and non-metallic objects it will detect, liquid, powders, whatever. Okay. And it operates by detecting a change in capacitance. The same change in the capacitance. In the previous case, where I have seen, there is a change in inductance. So in the change in capacitance. Okay, change in capacitance. So capacitive proximity sensors actually produce the electrostatic field. You know that the capacitive proximity sensor that produce basically the electrostatic field. You know, suppose the electrostatic field, okay, it produces electrostatic field. So when the object is basically comes, approach the sensing area, then what will happen? The capacitance of the both the plates, okay, the capacitance of the both the plates increase. So capacitance of the both the plates increase and resulting in the oscillator amplitude gain. Okay, so that means the amplitude gain, the amplitude will become high. Amplitude will become high. I mean, it will start oscillating. It will start the oscillating. Okay, so now the resultant amplitude gain triggers the sensor output switch. Resultant amplitude gain that triggers the sensor output switch. So that means what? When the object nears the sensing area, then what will happen? It enters into the electrostatic field, same like inductive transducers. It enters into the electrostatic field. Okay. So now changes in the capacitance in the both the plates. Okay. So because the capacitive sensors, as the capacitive sensors is attached with the oscillator, so oscillators will begin oscillating. Oscillators begin oscillating. Now, what is the function of this trigger circuit? Trigger circuit reads the amplitude of the oscillations. Okay, reads the amplitude of the oscillations. So when it reaches a specific level, the output state of this sensor changes. Okay, the output change of the sensor. That is the main block diagram, working, of the capacitive proximity sensors. So if we see in the diagram, if we see in the block diagram, suppose if we want to plot the waveform, so it is look like that. Suppose this is the amplitude, okay, oscillations, y-axis. This is the oscillations amplitude, okay, and this is the x-axis. If we plot, suppose this is your target or object, okay. So when the target is very very far to the sensing area, okay, so that means there is no oscillations, okay. So when it nears or it is very near to the sensing surface, then what will happen? The capacitance changes and the oscillators will start oscillating, okay. Oscillator will start oscillating, right? So when again it is taken away from the sensing surface from long distance, okay, so then what will happen? Oscillator will not start oscillating, so it will become simple straight line. So no oscillations, no amplitude variation will be there, okay. So in this area, so we can tell that this is the sensing area, okay. So this is actually the target present. In this area, the target present, and in this area, the target is absent. In this both of these areas, the target is absent, and middle portion, the target is present. Okay, so thus we can plot the waveform. Also, we can see for the function generator the waveform from the displacement. Okay, from the displacement, so we can plot the capacitance, oscillating waveform. Okay, we can we can analyze it. Okay, in the practical. So this is basically the working of this capacitive proximity sensors. Okay, and industrial uses, that is like industrial inductive proximity sensors, that is used for the production automation machines. It also used to count the products. So it is used also the filling process. Okay, pipelines. Okay, fluid level composition and pressure measurement. So this is there are so many industrial uses. This capacitive proximity sensor is used. Okay, for moisture control also, you can control the moisture through the capacitive proximity sensors. So there are various wide applications of the inductive capacitive proximity sensors. Okay, and this is the advantages and disadvantages. That's like inductive proximity sensors, that is your contactless radiations, wide array of the materials that able to be detected, able to detect objects through the non-metallic wells. It's wide sensitivity band, and well suited to be used in industrial environment. Contains the potentiometer that allows users to adjust the sensor sensitivity. Okay, so there is no moving parts in the common application, so that's why that it ensures long service life. Disadvantage is a relatively low range through incremental increases for the inductive sensors. Okay, so high price as compared it is a high price capacitive proximity sensor. There is a high price, okay, as compared to the inductive sensors. Okay, so this is all about the inductive capacitive proximity sensor. Is it clear, the capacitive proximity sensors? Clear? Okay, so this is actually the basic basically important the important capacitive and inductive proximity sensors. So other than the capacitive and inductive proximity sensors, there are another proximity sensors, that is the optical type proximity sensors. Okay, so optical type proximity sensor is something like different, because here we have to use some transmitters, some light sensors, okay, some detectors you have to use for the optical proximity sensors. Okay, so I have not shown in the slide with the optical proximity sensors, because it is not too much important, but I am just showing the diagram, basic block diagram, what is look like the optical proximity sensors. Okay, so let me first draw. Suppose this is your first block. First block actually represents pulse generator. Okay, that is pulse generator. And so another elements here, suppose it is a light source. Another element, suppose it is a light source. Suppose you may take the LED or lasers, some optical sources. You have to use some optical sources, LED lasers. And here the suppose a photo transistor, suppose detector is there, light detector. Suppose here the photo transistor. Okay, is here your photo transistors. Okay, and this is your target. Okay, this is your target or object. This is your target or object. Okay. So actually here the DC supply you are giving some here DC supply. Okay, some DC supply. So it comes to the pulse generator, then it will come to the LED, drive it, and then this is the light transmitted. Some distances something is reflected receivers, and then it will come to the control. This is the control circuitry is there. One is the control circuitry. This is known as actually control circuitry. Okay, control circuitry, and then you will be getting the DC output. So actually what is happening here, there is a simple block diagram. It consists of first it is the LED. Okay, this is the LED, optical proximity sensors. First is the light source. One is the that means it detects detects, sensor detects the light. Okay, it transmits the light. Basically the LED means transmits the light. Okay, and one is the sensor is there, that is a photo transistor you can use, or you can use another optical detector like PN photo detector, or pin photo detector, whatever. So basically detects the light reflected from the target. Okay, so LED generates the light. So LED generates the light, LED or laser you can use here. Okay, so what is happening here actually, you see very simple applications. Basically when the light is LED transmits the light, LED transmits the light, there is a sensing object, there is a sensing object. Okay, so light is get reflected from the sensing object. Okay, light is reflected from the sensing object, and it is sent back to the optical detectors. Okay, it is sent back to the optical detectors. Okay, so that you can vary this distance also, you can vary the distance also. So accordingly that this range will vary. Okay, so the signal will vary. Okay, so you can take the several readings based on this moving of this sensor, this sensors or target, this sensor target. Okay, and so next what will happen, it comes to the control circuitry. So control circuitry basically function is that basically it balance the amplitude. Okay, it balance basically the amplitude, means match the pulse frequency of this pulse frequency transmitter with the light sensor. Okay, balance, actually match the pulse frequency of the transmitter with the light sensors. Okay, so that is the actually function of this control circuit. Fine. So next after that the final output, then you will be getting in that output voltage. This output voltage you will be getting. So now this DC output voltage, you may say that is proportional to the displacement of this sensing area. क्योंकि sensing area जितना vary करेंगे accordingly that you will be getting some displacement voltage. And to actually to be improve some better output voltage, provide better output voltage. So that's why the control circuit this block actually is required. Basically it match the pulse frequency transmission. Okay, so then they will be getting the better reading. Okay, you'll be getting some better reading. You can take the better readings. Okay, so there will be some no noise and no other variations, no disturbance will be there. Okay, so this is the basically the optical proximity sensors. Okay, so these are also several advantages. That small in size, first switching actions. Okay, and that is the not sensitive to any vibration and shock. Okay, so these are the several advantages. And application is that the same, that is application, fluid level control, fluid level sensing applications, suppose solids, grains, suppose another bulk materials, some level applications it is used, optical proximity sensors. Okay, security and safety purpose it is used for optical proximity sensors. Suppose any collision prevention. Okay, suppose in our car parking, our car parking sensors, maybe some optical some in the backside optical proximity sensors may be mounted. Okay, so there is some to prevent any collisions, so there the optical proximity sensors are used. Okay. Some color sensing application, some color sensing application proximity sensors may be used. Jam detection also, like elective proximity sensor also optical proximity sensor may be used in the jam detection purpose, covenant belt. So there is a various application, optical proximity sensors. So all the proximity sensors based on the same principles, there should be on sensing area and there should be on a displacement, about target. So you have to vary the target on a certain distance. So accordingly, you will be getting the output. Okay. Some inductance, if you use some inductive proximity sensor, they change in inductance. If you use the capacitive proximity sensors, the change in the capacitance in the coils. In case of the optical proximity sensors, obviously, so they have the change in the detections level. Okay, the power detectors, electric signals, because you are getting the electric signals, because light optical signals basically it transmits the light, it generates the optical signals, and detector function is that convert the optical signals to an electrical signals. Okay, so that's why that we are getting some electrical voltage detector by DC output voltages. Okay, so that will be changes. So that is all the follows the all sensors for the same principle, same method, but different arrangement is the different, alignment is different. Okay, so advantage is more or less same, the application is more or less like same. Okay, so this is all about the proximity sensors. I think that all of you have understood the basic idea of the proximity sensor. Is it clear? All the classification of the proximity sensors. Is it clear?
Yes.
Okay.
Yes.
Okay. So this is the optical. This is the proximity. Hall effect proximity sensor is not important. Don't need to study the Hall effect proximity sensors. Okay. Only the inductive, capacitive, and optical proximity sensors. Okay. So, friends, so optical proximity sensors is over. This topic is over. So next day we'll start the another topics. So okay, just for information that next day I will take on quiz test Monday. Okay. I will take a quiz test on Monday. That is based on the temperature sensors, pressure sensors, force sensors. Okay, topic is that manometers, bellows, Bourdon tube, diaphragms, and strain gauge, and RTD thermistors, thermocouples, and this proximity sensor. Okay. So next Monday I will take a quiz test. That is 10-mark quiz test. That is a MCQ based questions I will give. Okay. This is the first quiz test. And the second quiz test after mid semester we will take the second quiz test. So there will be some subjective. Okay. So this quiz test will be based on the MCQ. Okay. Only MCQ 10. Only 10 questions. So 1 into 10, 10 marks. Okay. So please respond your roll call. Roll number 1. Roll number 2. Roll number 3. Roll number 4. Okay. Roll number 5.
Present.
Okay. 6.
Present, sir.
7.
Sir, 3 also present.
7.
Roll number
2 also present. 7
okay,
present,
8,
sir.
8. 9. 12. 13.
Sir, roll number 12 present.
Okay. 13.
13 present.
14.
14 present,
16.
sir.
17.
14 present,
19.
sir.
20.
Present, sir.
21.
20 present, sir.
22. 23.
23 present, sir.